Bjoern,
So,
do you want
yeah,
to
actually,
start?
I'm going to start.
Yeah, great. Thank you.
So I suppose you can now see my screen.
Yes.
Yeah, excellent. Yeah. Okay. Yeah, this presentation actually will cover something, well, let's say a joint development effort between Dow and Siemens using actually the CAPE Open Physical Property Interface to generate physical property data for thermodynamic simulations using Flowmaster. So certainly a less academic topic than the one before, but for us in Dow it has let's say practical relevance when it comes to plant design. And let's say based on this development we are going to make a big step forward, and yeah, we would like to join or share the journey here with this audience. So this is going to be a joint presentation, and yeah, before we dive into the matter, I would say again a quick introduction just to get some background here. So Anusha, please start here with your introduction.
Yeah, as already mentioned, I'm Anusha GURRAPU. I work as a team lead and software engineer at Siemens Digital Industries Software, to be precise at Simcenter Flomaster as a product. Yeah, Bjoern, go ahead.
Okay, yeah, Bjoern ALTENDORF. I'm with Dow here in Schkopau, Germany. I'm part of the, let's say, engineering organization of Dow, dealing with process engineering. My focus is fluid mechanics and mixing, and yeah, some reaction engineering as well. Okay, on the ideation of this entire effort here, so if it comes to engineering calculation and the design of and rating actually of process equipment, let's say physical properties are key, and of course accurate physical properties are very important, and this is certainly not a surprise, especially for this audience here. Yeah, bad quality physical property data within the entire design process will have direct impact essentially on plant performance, plant operation, equipment cost, and last but not least, and very important, on process safety. So it's crucial really to use a consistent as well as yeah, a qualitative and good data set throughout the entire design process. Dow has had a lot of expertise within the, let's say, physical property modeling space. We know how to apply those models within our process modeling efforts, and I would say this is one of our, let's say, critical assets really for successfully designing chemical plants. Essentially, this process is typically very integrated. We use consistent property sets all through, and typically do this, let's say, within an Aspen environment. However, if it comes to, let's say, equipment design, especially concerning, for example, thermohydraulic equipment, this integration is a bit lacking. So whenever you design a pump or compressor whatsoever, or model a complex fluid circus, this integration is typically not as good as in the step before. So again, if you do not have proper physical property data in place, this process can be critical. Like most other chemical and likely also engineering companies, Dow uses a bunch of different application, commercial in-house tools in order to perform, for example, thermohydraulic calculations. So Flowmaster is one of our standard tools when it comes to hydraulic modeling, and has roughly 350 users globally. So there is a need here. You can see this with this numbers, and we typically use that tool for steady-state dynamic analysis of fluid systems. We design pumps, compressors, piping systems, and perform safety analysis, such as, for example, surge or water hammer evaluation, perform and shutdown calculations on this platform, as well as some additional, let's say, control, loop tuning, optimization. So all this, at the end of the day, hinges of course on physical property data as well. And in order to get data, let's say, between different platforms, you have to do quite some effort in order to make this happen, to really do this consistent approach between, let's say, all these different points in your design process. So as of now, so the status quo, if it comes to hydraulic modeling with Flowmaster within Dow, we have, let's say, 3 options to get physical property data into the modeling tool. First of all, Flowmaster as such comes with a predefined database. So in general, the data generation is quick and easy. However, you have a limited amount of components, and from time to time, of course, the property data doesn't really matches our in-house data, which can be a challenge. Let's say if you start venture in correcting those things, you generate additional sources of error. On the other hand, method number 2 would be just using NIST. Of course, that's also quite convenient. You have a bunch of pure components, some predefined mixtures. Also here, data generation is just a few clicks and you have it. Yeah. However, if you really want to do it right and use, let's say, in-house data, and we have a lot of in-house data, we often deal with complex mixtures, also, let's say, in the fluid dynamic space. And if you really want to use accurate data over a broad range of applications and different operation points, it's really tedious and time-consuming to get this data in. So you typically start with the generation of physical property data within, let's say, a tool like Aspen. Then you have to export it, then you have to import it into Flowmaster, have to do the fitting, and then you can deploy it. And let's say there are a lot of manual steps involved. And of course, if there's a lot of manual stuff, especially some stupid things like copy paste, you have a source of error. And of course, this can be also a problem if it comes to accuracy of results. So if you put, simply in the transfer process create an error, this can be really a problem. As indicated, of course, depending on the step, things get faster or slower, and of course, in the other direction, the accuracy increases. And essentially, at this point, let's say Cape Open or the Cape Open property interface comes into play, into the picture, in order to essentially close the gap between different tools platforms. In this case, call it Aspen, and oops, okay, someone else took it over here. In order to close this gap between those different platforms, we approached actually Siemens or Mentor and asked them if it would be possible to use the Cape Open standard in order to generate physical properties and transfer, let's say, in a kind of one-click approach, the data between in-house data and the modeling tool. And this is essentially where Anusha is going to take over and go a bit into the details.
Thank you, Bjoern. Great. So I'll start with explaining who are we. How is Simcenter Flomaster useful to systems engineers in designing their models? Simcenter Flomaster provides an invaluable support to design efficient and safe thermofluid systems. It is a comprehensive solution for modeling thermofluid systems of any size and complexity. It can be used by an engineer to build the digital twin of their thermal fluid systems, to understand the behavior of the system anywhere, anytime, and ultimately to reduce risk, cost, and the development cycle. So here I'm going to talk about the demo of the piping system in Simcenter Flomaster, which is created automatically by importing from 3D CAD. So here we selected a file, we read the file and giving some input data which is not part of that PCF file. Created a network, and when we open the network, this is the automatically created network from the PCF file, and all the geometry data is imported into the components. So this automated creation from CAD saves up to 90% of the time in model creation. So here we are setting up some boundary conditions of pump and reservoir and some valves which were not part of the CAD import file. and setting up some data required to run a simulation. Doing the same thing on the other side of the network. Setting up some. So here you can notice that we didn't set the valve opening ratio in that valve, but instead we set a flow rate. So this is a scenario of the flow balancing where we know what's the flow we want to achieve, but we are not sure about the geometry of the data. So we have best in-house flow balancing capability and the steady state solver. So here we ran the simulation and you can see the results are automatically visualized on the schematic. So in order to achieve that flow of 0.04 meter cube per second, the valve ratio should be of 0.5 opening. With minimum changes, we can reuse this model to run a transient simulation and analyze different behaviors. And while you're running the simulation, you can see different results can be visualized on the schematic. So the user can directly know what's happening in their system without going into the details. And we can also find some critical sections of the network by defining some constraints. So here automatically that section of the network is highlighted, which doesn't match our requirement. And you can go and look at the results in detail. So as you have seen, Flowmaster is all about fluids and analyzing fluid behaviors in the systems. So in order to do that, we use lots of fluid properties, and we also support some fluid property providers, as Bjoern mentioned earlier, such as NIST. But for the reasons Bjoern explained earlier, we believe implementing Cape Open in Flowmaster will give our users more flexibility to create different fluids, access to different kinds of fluids rather than restricted to the fluids which we support in our database. So it started, the journey started with Dow, our stakeholders requesting for Cape Open to our product team. And the product team informed us of the the development team about Cape Open. And you can see from here that our customer was not at the start and end of the process. They were part of our development process. This is us being agile and lean. Either directly or indirectly through the product team, we always communicated with the customer, in this case Dow, to make sure that we are developing what they asked for. So after we know about the Cape Open, we started reading about it on the website, and we have contacted COLAN. In this case, Michael, the technology officer, Michael Pons. So, and we got, they were really helpful, and we got all the information needed to get started. So we did some investigation and concluded that we could use Cape Open to create curves and surfaces that represent the fluid data and create a characterized fluids and save in Flowmaster. And then the next question we need to answer was which PMC to use for testing all this functionality. So as Bjoern already mentioned, they were using Aspen, so we thought we should use Aspen to test our functionality. And through Dow, we contacted Aspen, and we are not the competitors to Aspen. As you know, as you have seen, the Flowmaster is a simulation tool where Aspen is a different product. So through Dow, we contacted Aspen Tech and requested for Aspen Properties license so that we could test all this functionality. And we had a go at implementing the Cape Open interfaces. And how did we start that? Here I'm going to give a very high level architecture. I'm not going to go too much into technical details at this stage. So these are the Cape Open property package managers which are installed on our machines. So we were having some issues about the COM and Windows, but I'm not going to talk about it because yesterday, based on the presentations, I understood that COBIA is the answer for all of this. So I don't want to go into that about the COM issues here. So first, Cape Open interrupt, we implemented this layer. This is where the material object is created, and this where the Cape Open interfaces were implemented. So this layer communicates with the K-Open property package managers through the interfaces we implemented, and it gives the required fluid properties at a requested state point like temperatures or pressures. This is our Flowmaster application. In this case, now it's a PME in terms of K-Open terminology. And we implemented a layer to communicate between the Flowmaster product and the K-Open interop. So this is where Flowmaster requests different fluid properties like density or viscosity, etc., at different pressures and temperatures for a particular fluid. And once we got all the required data, this is our fluid creation layer, where we create curves and surfaces from the data retrieved from property packages. And these curves and surfaces will be assigned to a newly created fluid, which I'll demo in a minute. So in terms of development timeline, after the initial conversations with Dow, as a proof of concept, we implemented the K-Open interop layer, which I just mentioned in the previous slide. We implemented that layer, and we started with a simple console app, Windows console app, rather than directly connecting into a Flowmaster as a first phase. So through this console app, we successfully made a connection and queried K-Open property package managers and got all the available property packages back. And then we requested for some fluid properties, and we got all the data back. And we tested that the fluid properties which we got back is as expected. So we did replicate the Flowmaster fluid generation process through this console app, which gave us confidence that it will work in Flowmaster when everything is plugged in. So after the proof of concept is successful, we did the entire development we plugged in the Flowmaster and all of that's done. And as a part of this, we used some, as a part of testing, we used some example property packages like tea or water suggested by Colan. By this stage, we achieved the end-to-end workflow of creating fluids from Flowmaster using K-Open property packages. We are very grateful to Dow and Aspen Plus for providing us the license of Aspen properties, which is used by Flowmaster. So after the example property packages testing, by that time we got license for Aspen properties. So we used Aspen properties for testing, and that's all fine. And last week we delivered this functionality to Dow for beta testing. And the first customer ship with this functionality is going to be in 2 weeks' time, that is in the end of October. All this happened in a time frame of January to October this year. So we do 2 releases every year, one in April and the other in October. We organized our backlog and priorities so that we could deliver this functionality to Dow in the earliest release possible. So here I'm going to demo. This is our Flowmaster application. In the materials section, we have a new K-Open fluid. This is the entry point. When I click on that, you get this wizard. Fluid name, you can give any name by which name you want to save this fluid in our database. And currently we support the incompressible, that's liquids and gases. This is the path where you want to save. And here, these are the property package managers which are installed on my machine locally. Some are example property packages and some are Aspen. So if I select Aspen properties here, fluids in the K-Open terminology, these are the property packages, but we use fluids because that's the term we use in Flowmaster. So these are the fluids which are available. These are the property packages which are available for that Aspen property package manager. And these 3 are by default which we got from Aspen properties, and this is something which Dow sent us. Aspen properties example. So when I select that particular property package, I get a list of compounds. In this case, these 2 compounds are part of that property package. So I can set a certain fraction. Because we are generating surfaces, so you based on the validation, you can generate up to what range you want these surfaces to be generated. So these are the pressure and temperature ranges, and the fluid info section, this is just for information. For these compounds which are, there are some constant properties, just for the information. And when I click on generate, so this is where the feedback of all the surfaces creating, which we need, like conductivity, specific heat, compressibility factor, viscosity, etc. And I got a fluid generation is successful. Once I get all the surfaces are created, and I created a fluid, and these are the surfaces which was generated just now and saved. Sonic speed is another surface. For say OK, so that's under the user defined catalog, we just created this fluid. And if you need that information, if you go to the description, all the information of which property package manager or the properties and everything is, you can go back and have a look at this. And all the surfaces are also saved in the database if you want to review them later. And these surfaces, if you want to have more accurate, you can change the tolerances while you're generating so that you can get at closer points. It again sets a time of accuracy versus speed. It's a user's decision. So that's the demo of the fluid creation in Flowmaster. I would like to say a huge thank you to Bjoern ALTENDORF from Dow and Michael Pons from Colan, who were always available to answer our questions, and to Aspen Properties for providing us with the test license. Thank you.